So now we are ready to begin the fourth part of our course, which is to build the formal quantum theory. Now, I want to stress really that the centerpiece upon which we will build this theory is all going to come from the de Broglie hypothesis. So we're going to build upon de Broglie. And I'm not going to rewrite it again for you here. It's important enough that it bears reminding. I'll just give you sort of the express version of writing this down. We're going to build upon de Broglie, where we learn that quantum events, right, are random. And the point, though, that it's not complete chaos. They occur with a predictable probability distribution, which is proportional to the square of some amplitude psi, where this complex amplitude psi is computed in the usual way as a superposition of waves, and those waves have particular features, namely a specified wavelength, which is Planck's constant over the momentum of the particle, and they also have frequencies determined by h nu equals the Hamiltonian. So we're going to be building upon that. Now, to construct the formal quantum theory, we basically have to go back, because we're doing quantum mechanics, we're thinking of mechanical systems, but we're thinking of them, what we know about them now, in light of all of this new information that's now been so well summarized in our de Broglie hypothesis. But because we're doing mechanics, we basically have to go back and rethink all of the classical mechanics that we've learned. Because although it isn't exactly true, it still has a very good intellectual framework that we can build upon. So we're going to be rethinking step by step our classical mechanics in light of all of this new information coming from de Broglie. In particular, what that means is we're going to start just like you did in classical mechanics. You may recall, it's been a while, but in your very first physics course, the first piece that you talked about is something called kinematics. And you will recall